In this video, we're going to go through topic 5, section 4, which is titled Logarithms. In this lesson, we will evaluate and simplify logarithms. So logarithms are the inverses of exponents. And so if I have something in exponential form, I have something like b raised to the x power equals y. So in words, the base raised to an exponent is equal to a result. So an example of that is if I have 3 to the 4th power, that equals 81. So the base of that is 3, the exponent is 4, the result is 81. That is equivalent to the logarithm log base b of y equals x. So what this means is that the logarithm with a base of b of the result, this is also called argument because it's not the result anymore, is equal to the exponent. So what that means is that a statement that's equivalent to 3 to the 4th power equals 81 is log base 3 of 81 equals 4. And so what we're going to be doing in this first example, example 2, is convert between the two forms. And so this first example really is the same as what was given in that graphic, but so that we can kind of look at how that's connected, we're going to do that by hand here. So when I'm given exponential form and I want to rewrite it in log form, what I'm going to do is I'm always going to start at the base. So no matter which way I'm changing, I'm going to start at the base. So I could be going in a clockwise loop, I could be going in a counterclockwise loop. It really just depends on which side of the equation the base is. So in this exponential form, the base is on the left. So that means I'm going to go to either side of the equal sign. So I'm starting at the base and I'm going to go that direction. So what this means is that since I have a base of b there, I would set that equal to, I would then go from the y to the x. So what that means in terms of our values, if I start with the b here, if I have a base of 3 and I'm doing this, that tells me log base 3 of 81 is equal to 4. So then for part B, if I start with the base here is 2. So I would be doing log base 2 of 8. And then I'm going back to the other side of the equal sign is equal to x. Okay, so when I'm converting from exponential form to logarithm form, I'm starting with the base, whatever that number is. I'm writing log with that number as a small subscript. And then that's of the result. So log base 3 of 81 equals the exponent equals 4. And then for this other one, I had 8 equals 2 to the x. So the base there was 2, so that means I'm doing log base 2. So since 2 was on the right side of the equal sign, I then put the argument as the number that was the result from the starting problem, which was 8. So log base 2 of 8 equals x. In C and D, we're going backwards. So what's going to happen here is we're still starting with the base. So this time we're going to go b to the x equals y. So that's how those two are related to one another. So if I'm doing that with log base 10 of 1,000 equals 3, I'm starting with the 10, and that's going to be raised to the 3rd power, equals 1,000. So then another example of that is 9 to the 1/2. Remember that a fraction power is like a square root or cube root or whatever kind of root based on that denominator equals 3. So log base 9 of 3 equals 1/2 is equivalent to 9 to the 1/2 power equals 3. So on our calculators, or on all calculators, some will have some where you can change the base. they include what's called the common logarithm and the base 10 logarithm. Well, the common logarithm, which is a base 10 logarithm. So that common log is, they drop the base of 10. So in this problem where I had log base 10 of 1,000, really that could be, I shouldn't write that, I shouldn't X that out. That is equivalent to log of 1,000 equals 3. So those are the same statement because that's a common logarithm. So the base 10 is implied. When you see just log, you should know that that means that the base is 10. So when you see log x, you know that that means that the base is 10. Or if you're solving a problem and you have log base 10, you should know that you can drop that 10. Similarly, we have something called the natural logarithm. The natural logarithm has a base of e. Remember that e is Euler's number. That's about 2.72. And it's an irrational number like pi. So that's why they're using a symbol again for that number instead of writing that number with a bunch of dots. So the natural log is written as ln. That's a lowercase ln. A lot of times when kids write stuff, they think that's in. It is not an I, that is an L. So think about that as log base e of x. And so those mean that ln of x. So sometimes when you have something that says ln in it and you're changing between bases, you add the little e subscript to denote the base. So it's sufficient to do it with the ln or to rewrite it as log. That wouldn't be something that would be marked as incorrect. So for example 3, what we're going to be doing is rewriting or finding the value of these log expressions. And so when we're doing that, what we want to do is think about it in terms of its exponential equivalent. And so when I have something like this, so this expression, this means five to what power is equal to 125. Okay, so what this means is that if I were to think about it in exponential form, I would need that value over here. So if I'm writing this and I want to switch it to exponential form, I would do 5 to the x power equals 125. And so notice that just switching that to exponential form translates that sentence perfectly. So if I have 5 to the x equals 125, x is not missing power. So I want to know 5 to what power equals 125. And so if we think about this, 5 to the third power equals 125. And so what that means is that x is 3. Okay, so that means that the answer for this log base 5 of 125 is the number 3. Then if we look at B, so if I switch to exponential form, I have a fraction happening, which might complicate things a little bit. So if I have log base of 1/4 equals 16, and remember that we want to take and set that equal to x so that we can switch to exponential form. So that means that I'm going to evaluate this as 1/4 to the x power is equal to, not 1/16, is equal to 16. Okay, so one thing to kind of think about is if I have 1/4 and I raise it to a power, that fraction's not going to go away. So let's kind of play with some numbers here. So if we think about, if I were to do like 1/4 squared, and I would have to square the 1, which would be 1 over 4 squared is 16. So remember that a negative exponent flips a fraction. So if I think about this way, then if I want to flip this fraction, if I do 1/4 to the -2 power, that would be equal to 4 squared, which is 16. So what that means is that our answer for this one so x is equal to that value of -2. So this exponent, -2, is going to make that statement true. So 1/4 to the -2 power is equivalent to 4 squared. So if I flip the fraction and change that exponent to positive, which is how I get that value of 16. So that means that for part B, x must be -2. So then looking at C, if I put this equal to x and switch to exponential form, so I'm going to start at my base, which is 3. 3 to what power equals 0? So remember that like 3 to the 0 equals 1. And then if I were to do like 3 to the -1, that's going to be 1/3. This is never the case. So I can never have an exponential equation that's equal to 0. And so that means that this one has no solution. So then for D, we want to put this equal to x, log base 2 of 2 to the 8th power equals x. And so if we do this and switch to exponential form, our base is the log is 2. So we're going to raise 2 to the x power. Notice that because we're always putting it equal to x, that left side's always going to be the base of the log equals to the x power. Because that's the nature of how we're setting this up. This time it's equal to this whole argument. So the argument of this was 2 to the 8th. In each of these before, it was just one number. And so that number was by itself. In this case, we actually result with another exponential equation. And so this should make this problem easier if I think about this. If 2 to what power equals 2 to the 8th power. Since these bases are the same, I can ignore them. So that means that x is equal to 8. So the answer for this is 8. One way that we'll learn later is that if I have log base 2 of 2, these are inverses, so it cancels out and just leaves the 8. But right now we're just looking at this in terms of that definition. For this last example, we're actually just using a calculator. So this is asking us, what is the value of each log expression to the nearest 10,000? So 10,000 means that we're looking at 4 decimal places. And that's pretty common when we're looking at things like logs because these are irrational numbers in the sense of what we're doing. So I'm going to show this on a calculator that works the same as a like an iPhone calculator. And so remember that if you're using a calculator where you can see what you type, you're literally just typing in log 900. So you should have a button that says log on it. You're typing that button and then the number 900. Because this works backwards, I'm typing in the number 900 and then I'm pressing log. And so that gives me this value. I'm doing this to 4 decimal places. So that means that I'm looking at this 2 as being my last number. And after that 2 is a 4. So that means it's going to stay a 2 and not round up to 3. So I've got 2.9542. Then I've got ln of e as my next one. And so some of you, your E button might look like where it's like e to the x. And so if you have to use it that way, you would want to type this in as e to the 1 power. Again, only if it makes it as a decimal. If you don't have a button that just says the letter E on it. So this one does have a button that just has E. It doesn't have E only as an exponent. So when I do this, I have to type E. And again, see how that's 2.72 is the average rounding for this because it's 2.718. And then we'll hit the ln button. Again, that's an L, not an I. And that gives us an answer of 1. So ln of E is 1. And so if we think about that, that's because ln of E is the same as having log base E of E. And so that ends up canceling in a similar way that we had for D. So technically that has an exponent of 1. So remember how this 8 became our answer. So that's how that 1 works there. And then for the last one, we've got ln of negative 1.87. So I'm going to type 1.87, make that negative, and then take the ln. And so notice that it says invalid input. When it says something like that, that means that this is undefined. And ultimately, what's going on here is that you cannot evaluate log of a negative number is what we saw here. And then in problem C, up here in the previous example, it gave us a no solution in the same way. So we can't evaluate the log of 0 or a negative number. So that's true for any log, not just natural log. So remember that it could be any log that it's asking us to evaluate with a negative that will not have a solution in the same way that in example 3C, there was no solution. Okay, so that's just a quick introduction to the relationship between logs and exponents. So your homework will follow through with what these examples were. Again, make sure you have a calculator so that you can do that last set of problems.